Hello everyone. Today let us discuss about spherometer and how to measure the radius of curvature of a spherical body using spherometer. So children, today let us learn about this spherometer and how to measure radius of curvature for a spherical body. So this is spherometer. Okay. So here also we have two scales like how we have discussed about vernier calipers earlier. In the same way we have here also this is the main scale. We call it as the pitch scale, this one. Okay. And this is the circular scale. So here on the circular scale, if you see, we have 100 divisions are there. So always this 0 of this one should coincide with the 0 of that in the flat position. Flat position means we have to first keep one glass slab and keep here the spherometer like this. Okay. Okay. So now you just close it like this. So it should exactly touch. So how we can know whether it is touching? For that, no, you take a strip of a paper. Okay. So you have to keep down. If paper is not going at the side, that means this is the right position. Okay. Yes or no? Got it. So now here paper is not going. So when it happens like that, you have to see now. This 0 should coincide with the 0 of the main scale. So now you can see here is the 0 and here is the 0. So they are coincided. So here we don't have any error. Okay. So after that, let us first find out the least count. Like earlier vernier calipers and screw gauge, how we have found. In the same way we will find. First we will see pitch. Pitch means the same thing, that distance traveled by this circular scale, that is how many rotations it will make on the pitch scale. So divided by how much distance it has moved divided by number of rotations. So from that we can find pitch. What is the pitch for this one? 1 mm. 1 millimeter is the pitch of this one. So least count is equal to pitch divided by number of circular scale divisions. Okay. So that is equal to pitch is equal to 1 mm. Circular scale divisions are 100. Yes or no?
Yes, sir.
So we have divided by 100, that is equal to 0.01 mm or 0.001 cm, centimeter. So when this 0 of this one coincided with the 0 of the main scale, there is no error. But in some cases there will be error. In some cases this will go like this. In here, just I am showing you, this doesn't have error. It may be like this. On some other cases this may be like this. Exactly this 0 may not come straight to the pitch scale. In that case we have to find out positive error and negative error. So how to calculate the error? So you can go through this manual. So how many divisions it has gone, calculate the number of divisions, that is positive error is equal to, for example, 6th division is coinciding, 6 into least count, that will become 6 into 0.01 mm, 0.06 mm, that is the error now. So when you are making zero correction, you have to subtract it 0.06 mm, just like our screw gauge. Okay. So in case of negative error, which division is coinciding? For example, let us assume 95th division like this. This is 95th division, like this it is coming. Here you have 90, this is 95. If it comes like this. So in this case, we can say it is negative error. Suppose if this is like this, 0 above, this is fifth one is coinciding or sixth one is coinciding, that is positive error. Suppose if it is like this, this is 0 is above, then this will be negative error. In case of negative error, how to do now? So just like our screw gauge, how we have to do, that is equal to, if it is 95th division is coinciding, minus 100 minus 95 into least count. So that is equal to 100 minus 95 is minus 5, least count 0.01 mm. So that is equal to 0.05 mm with negative sign. So this is the zero correction. So we have to see whether it is positive error or negative error. Depending upon that, either you have to subtract or you have to add. Okay. So here this will become, you have to add it. This will become minus of minus 0.05, which will become plus 0.05 mm. So like this, you have to first see what is positive error and what is negative error. Okay. After that, take this spherometer, release this little up, take onto your observation book and just stretch, press it like this. Okay. Press it like this. Let the prick marks be there. Okay. I hope you are seeing now. Yes or no? Yes. So take this one and this one. So mark them as A, B, C. Okay. So now join them. Yes. Take a scale. Join A, B, C. Carefully do. Yes, after that measure each side. Okay, so let us measure them. This one is AB is 4 centimeters and measure AC. This is slightly more than 4, that is 4.1 centimeters, and BC is 4 centimeters. So take the average of all of them. Take the average. So average of all of them. So that we will take it as L is equal to 4 plus 4.1 plus 4 divided by 3. So that will become 12.1 divided by 3, that is 3/4.03 approximately centimeters. Okay, keep it like that. Now next what we have to do, we want to find the radius of curvature for this one. So how it will be, for us it looks like this, but it will make a ball like thing like this, full ball like thing. You have to imagine like a spherical shape. So like this you have to imagine, like this. So our glass is like this here on the top. So for this circular shape, we want to find this radius. So that is what we are doing now, radius of curvature. So for that, what we have to do now, first thing is make a tabular form. Serial number. First you take any position. So here let us go with a normal position. Normal means on the glass slab we will take. So here we will take again on the glass slab main scale division and circular scale division. Next circular scale division into least count. Let this be A, let this be B, and A plus B If there is error correction, you have to make final reading with error correction. Okay, then after that, this is all for on a plain glass slab. Again, you take the readings on the spherical surface. Once again, you take, let it be H1. So here you take again main scale division, let it be A, and circular scale division, Next, circular scale division into least count, let it be B. Now A plus B is the final reading, and if there is any error correction, with error correction make the final reading. Now this will be H2. Now start one by one. We will take one reading. So take this. Now exactly the surface should be flat. No ups and downs like books and all. You can remove all books and all. So keep perfectly on a flat surface. I'll remove the book so that it should be on a perfectly flat surface. Nothing should be there under. Remove all the pens and this one. Keep it on the slab like this and keep it like this. Okay, this is the pitch scale and this is the circular scale. Now rotate it like this until it touches the bottom. You can hear that sound. Yes or no? Yes or no? Yeah. So now when that happens, no, you test with this strip of paper. If paper is going that side, that means there is a gap. If paper doesn't go, that means there is no gap. So when there is no gap, now check the reading. In my case, you can see here perfectly main scale is 0 and also pitch scale is 0. In this case, always it may not come like that. Okay, so but in this case we got main scale 0, circular scale 0, circular scale into least count, this is in millimeters, mm. So here A plus B, that is 0 again. Final reading, no error, like this. So like that you take 6 readings like this. And take the average of all of them, that is take average, add all these 6 readings divided by 6, you will get that value. Okay, and after that, next remove this glass slab, take this spherical surface. Now on the top of the spherical surface, now you keep like this. Now you can see here it is falling like this. That means it's not in a position. These 3 legs should touch this surface. 3 legs should touch. That means release it like this and slowly make it go and touch the bottom. You can understand when it touches. You will feel that sound, little sound. If you cannot hear the sound, we can test with the paper. So if paper doesn't go like that, paper strip, it doesn't go like that. That means here it is in the position now. So now what we have to do again measure the main scale division. So main scale division now. Here you can see this is 0, 1, 2, 3, 4. Fourth division of the main scale. Yes, children?
Yes.
So on the spherical main, coinciding circular 1. So here it is 0, 10, 20 and this is 30. So this is 20, this is 25, this is 26. 26 you can see, no? I think. Yes or no? 26th division is coinciding. Yes or no? So now write this as a 26th division which is coinciding. Now what you do is 26 into least count 0.01, that is 0.26 millimeters, because we took least count in mm. So A plus B, A is 4, B that is 0.26. Okay, so that will become 4.26 mm. 4.26 mm. Yes or no? So then if there is any error, you have to do with the error. If no error, this is 4.26 mm only. So here also once again you go for 6 readings. Take average of these 6 readings. Add all of them divided by 6 and you will get that value. So here this is H1, here this is H2. Now you will get H1 and H2. Therefore H is equal to H2 minus H1. H is equal to H2 minus H1. So we want the now radius of curvature. So radius of curvature has a formula. We have this formula. R is equal to L square divided by 6H plus H by 2. So that will be your answer finally. Because we have done in millimeters, you may get the answer in millimeters. Suppose if you take the least count as 0.01 mm, proceed with 0.01 mm. Suppose if you take 0.001 cm, proceed with cm, centimeters. Depends on how you take. So finally you will get the answer using this formula. R is equal to L square divided by 6H plus H by 2. L means this is the one which we got, that is AB plus BC plus CA. L means which this one. AB plus BC plus CA divided by 3, where we have taken, no, this is AB plus BC plus CA divided by 3, that is L. H means this is what? Difference between the flat position, that is on a glass slab, and the spherical surface. First time write it as H1, second time you write it as H2. Take the difference of them after taking the average and finally calculate radius of curvature like this. Okay. Finally you write the result. Okay. Shall we close?
Yes.
Okay, children. Let us meet in the next video. Let us meet in the next video with another. Thank you for watching this video. We will meet in the next video with some other topic. God bless you all.